Do you have any loose outlets in your house where you plug something in and it just falls out? Or just need to replace an outlet for any other reason? Replacing them is actually really easy and really cheap. But a lot of people, even sometimes professional installers and electricians, will make these 7 mistakes. And the results can be shocking. Sorry, I'll see myself out. The first mistake is leaving loose connections. When you're attaching a wire, this may feel pretty tight, but over time, that little bit of wiggling there, that's gonna lead to oftentimes that wire separating just a little bit, and it'll cause your lights to flicker. It'll sometimes cause the outlet to heat up, and you'll get some discoloring of the outlet itself. If you start to see any of those kinds of signs, you may have a loose connection. Now this may seem kind of harmless, like I can deal with my lights flickering a little bit. But when that connection is being made and then being disconnected and made and disconnected, it causes a lot of heat, which can lead to a house fire. In fact, loose connections in wiring account for more house fires than any other electrical issue. And that sudden connect, disconnect, that's also gonna kill the circuit breakers. Whichever circuit that it's on, that breaker is gonna trip more often, and it's not gonna last very long. Now I mentioned you may notice one of these existing because lights will flicker. If it's on an outlet, you might wonder, how are lights flickering? But if you have power that runs through an outlet before it gets to the light switch and to the light, it could be an outlet that's still leading to that light flickering, or it could be a loose connection on the light switch itself. It might make it difficult to figure out where exactly that loose connection is taking place. One telltale sign is if you hear some kind of electrical crackling sound. If you hear that crackling is happening right where that loose connection is taking place. You can, if you also happen to have like a thermal imaging gun, which you probably don't, but if you do, and it can show you hot spots, you'll find that wherever that is taking place, so you could shine it on the outlets and the light switch and wherever, and you see one of those outlets is a lot hotter than the other ones, that's probably the one where it is, because again, that loose connection is gonna cause a lot more heat. You can also use a multimeter like this to look for fluctuations in voltage. If you see that, that's a telltale sign that there is a loose connection, but it's not necessarily going to hone down exactly where in the circuit that loose connection is taking place. Now, you may think that your outlets are all safe, but wait till you hear about the hidden dangers in using the wrong type of outlet. If you're using a regular outlet, an ordinary outlet in a place where you should be using a GFCI outlet, well, that's like leaving your doors unlocked in a pretty bad neighborhood. A GFCI stands for Ground Fault Circuit Interrupter. Basically what it is it's kind of like a little circuit breaker right there in the line inside of your house. There are certain places in a residential application or in an office, a commercial application, but there are certain places where a GFCI is required. Typically, any circuit with outlets in a kitchen or in a bathroom or in a garage usually requires that one of those outlets be a GFCI. Now, you don't need to have more than one of these outlets in that same circuit, because if any outlet that's downstream of the GFCI, if any one of those pulls too much amperage, it's gonna pop the GFCI. So having more than one doesn't really add any extra protection, but it can add extra complication. I've seen instances where the same circuit goes to 2 different bathrooms in a home, and there's a GFCI in each of the 2 bathrooms. So you're in one bathroom using a hairdryer, you pop the GFCI, but you don't pop the one in that bathroom, you pop the one in the other bathroom. And then you're wondering why you can't get it to work again because you're pushing the little reset button in the wrong bathroom. Put only one in the circuit, that's what's required by code typically, but of course you need to make sure you know the code in your jurisdiction. But in case you haven't seen one before, here's essentially how it works. You have this outlet, usually there's oftentimes, not always, but there will be a little indicator light like this one, which isn't showing anything because it's not connected to power, but that light will be green if there's power running to it, or it'll be off in some cases. Then what happens is if too much power is drawn, for example, this is a 20 amp GFCI. So if more than 20 amps gets drawn, it's going to pop. You can also test it by pushing the test button, which this particular outlet recommends doing monthly to test it and make sure that the functionality is actually still working properly. When that button is pressed or when too much current is pulled, it will cut off any power to both this outlet and anything downstream of this outlet, so anything that comes after it. And then usually you'll get a little red light that shows that the power is now off. Now, when you use a GFCI, you need to make sure you use one that's the right amperage. If you're on a 15 amp circuit breaker and you install a 20 amp GFCI, well, the circuit's gonna pop before the GFCI does, and so the GFCI is doing absolutely nothing. When it pops, what you do is you just turn off whatever things were drawing power from it, and you go press the reset button, and it's going to turn green again, and you're good to go. If you press the reset button and it won't turn green, it means something is still pulling too much power. This is intended in rooms like your kitchen, again, a bathroom, a garage, that if you have something that's drawing too much power, it could be like a blow dryer that got set into a sink that's full of water, and now all of a sudden there's an electrocution situation. Or a toaster that got dropped into the sink, or any number of other things, just because those rooms often have some wet use cases, and they're just situations with appliances where somebody could be injured, and when that happens, it's gonna draw a lot of power. And so it's gonna have an instant shut off of that power. But in order to prevent it from popping a circuit breaker somewhere, you know, in the garage or somewhere else, it's right there locally. It's just gonna be quicker, and then it's easier to reset when you just had too many things plugged in and running at the same time. You also need to understand which things in your home need to be on that GFCI circuit. In a kitchen, there are lots of places where the microwave doesn't need to be on that same circuit, which is pretty great because a microwave draws a lot of power when it's on. But the microwave isn't very likely to be dropped in the sink, at least not a mounted microwave. So if you have an outlet that is in the location that's intended for the mounted microwave only, you don't need that one to be on a GFCI. Again, check your local regulations to make sure that's accurate for you. Okay, so let's say you have installed, you know, an outlet like this, and you're wondering if you missed something or if something's wrong. Well, the final step that you should do, no matter what, no matter how confident you are, is you should test it. The easiest way to test it, I found, is with one of these plug-in testers. You can get one of these in a kit. That's an easy way to do it. If you already have a multimeter, or if you want to buy a specific type of multimeter and don't want to spend $100 on a kit like this that's got all three of them in there, three, meaning I'm talking about these three tools, that if you're going to do home electrical stuff, you should just have them all. You can also buy a kit that's just got these two tools. I've got the Southwire brand. I think I picked these up at Home Depot. Lowe's has the Klein brand, which is awesome as well. Definitely have these. A multimeter is really helpful too, but these two tools are going to do a lot for you. So when it comes to testing, here's how it works. You've got an outlet, you've got the power turned on to it. Literally all you do is you plug it in, and it tells you right here what each of the things means. There's 3 lights, red and 2 oranges. And it tells you right there, depending on what you get, exactly what's going on. Let's go ahead and just test this on an outlet right here. I'm just gonna plug this in. All right, I get 1 orange light in the center. What does that mean? It means I've got an open ground. That means that the ground here isn't connected properly, either at this end or at the other end. It's most likely here because, let's go test another one that's on the same circuit. Right here, in the same room, same circuit, that one's showing normal. The 2 orange lights means it's correct. The wiring is correct. So that means I may just have a loose connection on the ground right here, or for some reason that ground is it's broken somewhere. Most likely it's just a bad connection right there at the outlet. So that's something I actually need to fix because that outlet's not properly grounded, which makes it not very safe. It's more likely to hurt somebody if they were electrocuted from something in that outlet. Grounding gives the electricity somewhere to go other than into a person or something else, into an appliance or something else. So when a lot of current is being drawn because you're being electrocuted, then some of that is going to get diverted through the ground, and the breaker should trip. And a lot of that is actually done a ton to make homes and, well, everywhere, so much safer. The first home that I owned was a very old home in a rural town, and there was no grounding anywhere in the house. And so fortunately, I mean, we still had circuit breakers. Without a breaker though, you start getting electrocuted and that's it. You can be killed by that. But in a lot of cases now, you just get a little bit of a buzz feeling because of the grounding and because the breaker then is often gonna trip. Or in a lot of cases, in a bathroom, kitchen, or garage, a GFCI is gonna pop. Okay, next we gotta talk a little bit about stripping wire, which we talked a lot about in another video here on this channel. Links to All the related videos on this channel are in the description of this video, so you can learn a ton about electrical work, especially for your home. But let's go ahead and talk specifically about wire stripping for outlets and light switches. If I'm going to connect these 3 wires to an outlet, then I'm going to need to strip some off the end. Now, there's 2 ways to connect. I can either stick it through these little holes in the back, or in some cases like this, well, it's holes in the back where I still tighten down a screw to tighten that up. With this one, I don't need to tighten down screws, I just stick it in and it just holds it in place. Or you can do it to these screw posts by creating a hook, which I just cut this one off. So there's a hook there still, which I'll take off here in a second. Now, a couple things to note. There's the hot side, which is kind of a brass color, and then the more silvery color, nickel color, that's the neutral side. And then of course, green is gonna be your ground. And typical wiring convention is the black wire or red. Typically black is the primary hot wire. If there's a second hot wire, then it's usually red. Green or bare wire is the ground, and the white is the neutral. Another way to know for sure, in case somehow the screws got switched out, is it'll say right on there. If you look real close right here, it says hot wire there, and over here it says white wire. And on this particular outlet, these holes are small enough, they only work for 14 gauge wire, which it says right on the side. So the 12 gauge wire that I have here, 12 usually comes with yellow around it, yellow insulation or wrap around it. 14 gauge often comes with white for residential. But depending on which way I'm gonna do this is gonna impact how I strip the wire. If I'm gonna make a hook, then I wanna strip off about 1/2 inch or so. Basically just enough where if I just stick the end of the wire through the tool and roll it over and make a hook, just enough so that it's stripped clear right up to the bottom of the hook. I don't want it to go past that. But if I want to stick it into the holes, then I want to make sure that I'm stripping off only the right amount. If I strip off too little and then try to stick it into one of these holes, then there's going to be a lot of wire there, or a lot of insulation on there going into the hole, which is not how it's supposed to be. And then I can actually end up with a really loose connection, because a lot of times I won't even be able to stick the wire all the way in as far as I need to for a good strong connection. But here, if I strip off a lot, way too much like this, then when I stick it in, I have a bunch of exposed wire right there, and that's a safety hazard. That could lead to arcing and stuff, or wires get touched inside of the box, then you get sparks, you get fires, that kind of thing. We need to strip off just the right amount. Now, they make it easy to do this. Every one of these outlets, every one that I have here, basically all that I looked at the store, they all have the same thing, and it's actually a wire stripping gauge. This one's actually partially covered by the sticker that you're not supposed to remove unless you're gonna use these other terminals down here. These terminals, by the way, are for if you're gonna have other outlets downstream that are protected by this GFCI. You run the wires coming in through these holes, and then you could run one going out to a non-GFCI protected outlet or light switch. But if you want it to be protected, it's gotta come out through these ones, and you have 2 holes on the bottom. I'll show you on this one so I don't have to remove that sticker. On this one, there's a little arrow right here, a little line and an arrow, and it says strip gauge. See that? So the length of that line is how much I'm supposed to strip off of wire if I'm gonna stick it into these holes. Here's how I might use that. I stick my wire there, and I know the length of that line comes to where my fingernail is. That's how much to strip off. That's it. So I could strip it from here down, and I'm good to go. And that's really nice that it's on all these different outlets and switches, because doing the right amount for a specific outlet is important. The amount I need to strip off for this isn't gonna be exactly the same as what I need to strip off for this, because how much I shove it in there is gonna depend on the outlet itself. So use the stripping gauge for the outlet that you're installing. Now here's another one that you're probably gonna be tempted to not do, and it's really important. Copper and aluminum do not mix well, and when we're talking about electrical stuff, they absolutely do not. If I have copper wire, which is most predominant today, if you're using copper wire but you also have aluminum wire, you're going to need to have some sort of connection between the two, and you can't just connect them normally like you would copper to copper wire. The reason is that the two metals, they react with each other, and then they're gonna end up corroding a bunch, and when they do, the connection won't be good. It'll ruin the wire. You'll end up with basically all the effects of a loose connection. And it could end up causing a house fire, or it could just at least end up causing the electrical system in your home to fail. So if you've connected from aluminum to then copper wire and then connect to an outlet, that outlet's just gonna stop working eventually. And that's honestly like the best case scenario. And the thing is that when you go to a home improvement store, all your outlets and stuff, they're all gonna be made for copper wire. Or you're gonna need to find one, and it's gonna cost you a lot more, but you're gonna need to find one that is acceptable for aluminum application too. But aluminum specific electronics, those are a lot less common. You're gonna have a lot less options at your home improvement store. Probably gonna need to order online, and it's probably gonna cost you a lot more. So they make these connectors. They also make a more typical wire nut style connector where you stick the two wires in and you screw the nut on. I like this one. I feel really good about the connection that's being made with these, but wire nuts work just fine too. Not a normal wire nut. It has to be specific for aluminum. The cost difference is substantial. For like two of these, today it cost me $13 for two connectors. But it's the only way that it can be done that works properly. How do these work? You strip the wires enough for these to be able to go in, and then you really just tighten down the little screws. It's a little flathead screwdriver, and it actually says right on it here, the wire gauges that it's rated for. It's really small writing, but this says 18 to 10. This is 12 gauge wire, so this is gonna work just fine. And that's kind of cool. These work for a wide range of wire gauges. And then on the packaging, it gives me a torque spec for those screws, how tight to tighten them down depending on what kind of wire I'm using. So if it's aluminum wire, if it's 12 gauge, it says 10 inch-pounds. If it's basically anything else, then 15 inch-pounds of torque. Now in a previous video, I talked about how you rarely see people actually torquing these down to a spec. A lot of people don't have a torque screwdriver. If you're gonna be doing a lot of electrical stuff, it's probably not a bad idea to get one. I'll link to a very cost-effective and affordable one in the description of this video. I have one. I don't usually use it for electrical work, but I think I will now because I wanna make sure it's done right, especially when I'm talking about connecting aluminum and copper. I want that connection to be solid. And so I just wanna make sure it's done right. So I'm just gonna set this by just screwing this. I pull it out and I twist it until I get down to 15 inch-pounds. There's just a little red line there. There, I'm at about 15 inch-pounds. And then I can just screw it in like normal, like a normal screwdriver. And once I hit that torque spec, we're gonna hear this just click. And that way we know that it's hit that spec. And it's not gonna keep turning unless you just then force it further. But if you let it click and then you back off and you let it click a second time, you can feel confident you've hit the torque spec. The places where I've seen this is on here. I'm curious if these even have a torque spec on them, but you do see them on circuit breakers as well. They'll have a torque spec written right on them, as well as on your breaker panel for all of the different bolts in the panel itself that need to be tightened down onto wire. There's a torque spec for each of those. And so not a bad idea to have one of these. I also use it for some outdoor applications, which is why I actually own it in the first place. Now wires come in different materials, copper and aluminum, but they also come in different sizes, and they come in different sizes for a reason. The amount of current that you need to be able to run through the wire, as well as the voltage that the wire is gonna run at, those two things, they really determine how much wire you actually need. When I was wiring my house up for a hot tub, or when I was wiring it up to be able to receive power from my generator, another video that I'll link to in the description here, but I was wiring it up to be able to receive power from a generator that I just plug in and feed that power into my breaker panel. It's pretty cool. And also when I was wiring up to a 220 volt receptacle that I used for welding. In each of those cases, I used this 10 gauge stranded wire. And you can see how this wire, there's just a lot more here than on these smaller 12 gauge solid wires. It's kind of like if you have a pipe for water, right? And you're trying to shove a ton of water through a little tiny pipe, right? What's it gonna do? Well, it's gonna build up pressure inside and it could end up bursting that pipe. Well, with electricity, if you try to shove too much current through too small of a wire, what's gonna happen is it's gonna melt down. That's kind of the equivalent of a pipe bursting. And when it melts, you end up with ruined wire, but you also can end up with a house fire. In most residential applications, 14 gauge wire is kind of the baseline. That's even smaller than what I have here. And that usually works for most outlets, lights, that kind of stuff, up to 15 amps. If you're gonna have any circuit with 20 amps on it, you need to go to 12 gauge wire. I run 12 gauge wire basically anytime I do a household project for a typical like lighting or outlets, that kind of stuff. I run 12 gauge wire. And then like I said, whenever I'm doing a bigger project, usually on the 220/240 volt projects, like to the hot tub or that's heated with electricity, right? Any of those kind of bigger projects, I'm using this like 10 gauge stranded wire. Now it's not just a problem to use the wrong size wire, but what happens when you put too many outlets on the same circuit breaker? It might seem really convenient. In fact, I've done this before where you've got a bunch of outlets in a room and then you're like, you know what? I could really use an outlet up higher on the wall because I'm gonna mount a TV right here. And so here's what I'll do. I'll just connect to an outlet that's just below it on the wall or nearby, and I'll run a wire straight up, and then I'll put in a second outlet up high. And you think, well, that's probably fine. In a lot of cases it is. But what happens when you have too many outlets on the same circuit? You start trying to draw too much power if you're using stuff in all those outlets at the same time. There's a bit of a balancing act here. Typically, like when we have too many outlets, we're likely to use all of those outlets, but not always. Sometimes it's just more convenient to have outlets in more places in a room, but most of them sit empty a lot of the time. I just know that in my home, there's usually stuff that's plugged in and that stays plugged in and that's often used. And if they're all being used at the same time and there are too many, you draw too much power. And what happens when you draw too much power? Well, you might think, well, maybe I'm gonna melt down my wire, or chances are what's gonna happen is you're just gonna be tripping that breaker and it's just gonna trip regularly. So one thing that you could do is if you're gonna need to add an outlet, just check and see how many other outlets you already have and what kinds of things you have plugged into them. If we're plugging in toasters and stuff like that in the same circuit and we want to add another one into that circuit, you might need to actually do the math. A lot of these appliances will tell you how many amps they draw at their peak, and you need to just add those up and make sure that it doesn't add up to too many amps for that circuit breaker and for the wire that's coming from that circuit breaker. If it's 12 gauge, you get up to 20 amps. But if we're running things like LED televisions, if we're running things like, you know, some lights in a room, maybe a couple of lamps, and occasionally you're charging some stuff, we're just not drawing that much power with any of the outlets, and so we're probably okay. Now, the NEC, who creates the national standard, which is kind of the baseline, but not the real standard across the United States, they don't even have a specific number of outlets that's the limit of what you can have. But a good rule of thumb is for a 15 amp circuit, not to have more than about 10 outlets to prevent overloading. And likewise for a 20 amp circuit, having up to maybe 13. But also you gotta keep in mind that a lot of the time, we don't just, you have an outlet with 2 receptacles on it, 2 spots to plug in. That doesn't mean that there's only gonna be 2 things plugged in, right? We stick these things in there that will allow for these 2 outlets to become 6 outlets. And then we put power strip into that so that we can plug 6 more things into that. You can end up overloading without having too many outlets. In fact, you could have 1 outlet and you could end up overloading an entire circuit. So the number of outlets is less of an issue than the things that are actually plugged into it. But sticking to that recommendation of 10 to 13 for a 20 amp circuit is a good rule of thumb to keep you from overloading, to keep you reasonably safe. But within your home, within your office, wherever you are, be careful not to overload your circuits. And if you start seeing the circuit breaker trip a lot, then we know that we need to, maybe move some of those things to an outlet that's on a different circuit. These 7 mistakes are easy mistakes to make and things we definitely want to avoid, but there are a lot of mistakes that we can make regarding our personal safety. And so when we're doing electrical work, we want to make sure that we have safety covered. You want to learn about electrical safety, let's go ahead and watch this video. I probably should have made the safety video the first video in this series because that stuff's really important. I don't know, people aren't really that interested in safety that much. But I think by this point, you've seen the value of that. So let's go watch the safety video next. I promise it'll be way more entertaining than most safety videos. We'll see you there.